let's work through a business example of game theory and look at the strategies of two firms. So we've got two firms, small and large, and these are firms that compete with each other on the basis of price. Each can choose either to set a high price or a low price. So the payoffs inside of this table give the profits that each firm would earn in each of the four possible combinations of strategies. So small, let's take notes of that. Small has two strategies. They can choose low or high. And the large company has two strategies, low or high. Let's use the method that we used in a previous video to try to figure out the answers to all three of these questions. So we're going to just start out by trying to find that Nash equilibrium. Now, as a reminder, a Nash equilibrium just means no regrets. When you get to a Nash equilibrium, everybody is playing their best response to the other player's best response, and that doesn't necessarily mean it's the best outcome for everybody involved. It just means that once you get to that outcome, nobody says, well, if I'm here, I'm actually better off choosing a different outcome. So let's start out by looking at what large would do. So what would large do if they knew that the small company is going to play the strategy low price? So we're going to cover up that high price and pretend it's not there just to keep it from distracting us right now. So let's look at their payoffs. And remember, in fact, it's just a good idea to go ahead and write these down here so we don't forget what they were. Player 1's payoff, player 2's payoff, player 1's payoff, player 2's payoff. Okay, so player 2 is always the one on top. So player 2 is thinking, well, I have the choice of $500,000 in profit or $600,000. $600,000 sounds better. Now let's think about what large will do if they knew that small was going to play the strategy high price. Okay, so we've covered up low price so it doesn't distract us. And again, that's player 1 is the first one, player 2 is the second, player 1 is the first, player 2 is the second. So they decide, well, should I do a high price or a low price? Well, the high price has a higher payoff, so their best strategy, player 2 or large's best player 2, their best strategy, if they know that small is going to choose high price, is to choose a low price. So let's move our little cover out of the way here and see what we have concluded so far. So if large knows that small is going to play low, they choose high, and if they know that small is going to play high, they should choose low. So let's answer the first one. Is there a dominant, actually we're on the second one here, is there a dominant strategy for large? So a dominant strategy means there's always the best choice no matter what the other player does. So the answer to this is no. Why? Because their strategy is not always the same. It's going to depend on what the other player does. So unlike in that prisoner's dilemma where both of our players had a dominant strategy, there is no dominant strategy, at least for the player large. So let's now turn our attention to small and see what small might do. So we've covered up one of the strategies that large might play. So this is assuming, so small says, well, what if I know large is going to play low price? So what would small do if we knew that large was going to play the strategy low price? What should they do? Okay, well, they can either have a profit of $200 or zero. Sounds like 200 is better. Well, in that case, they're going to play the strategy low price. Now, what should small do if they knew that large was going to play the strategy high price? Well, either they choose a high price and they have a profit of 400, or a low price and a profit of 600. So they're going to choose 600. So they play the strategy low price. So does small have a dominant strategy? The answer is yes. No matter what small does, or actually no matter what large does, small's best strategy is always low price. Okay, now let's turn our attention to part C. What is the likely pair of decisions? So if we saw this game played in the real world, what would the outcome be that we would expect to see? If we saw this game played over and over and over again by firms, what would we see them typically do? The likely pair of decisions is that Nash equilibrium, right? It's because once you get to an equilibrium, nobody has incentive to change their strategy. So the likely pair of decisions is that small plays the strategy low price and large plays the strategy high price. And the payoffs to that are small has a profit of 600,000 and large has a profit of 600,000 as well. So hopefully that gives you a better idea of how to use game theory in a game. And you can see that there's actually a pretty wide variety of applications to this kind of approach.